Hello everyone. In this lecture we are going to discuss another real-life situation, another word problem related to real-life problems. It's a mini engineering problem, perhaps you can say. Um, so again, we want to talk about why we learn all this math that we learn. The width of a square-based storage tank, this is a storage tank, and it's square-based, so all four sides are equal. Is 3 meters less than its height. Okay, so this is the height. We don't know what the height is. I called it x. Okay, and the width is 3 meters less than the height. That is x minus 3, according to the given information in the problem. And the capacity of this storage tank is 20 cubic meters, according to the given information. If the dimensions are integers and in meters, find the tank dimensions. Okay, so we need to find the dimensions of this tank whose capacity is 20 cubic meters. Okay, so how are we going to solve this real life problem? It's a mini engineering kind of problem. We know that in a rectangular prism, the volume is length times width times height. Okay, so we're going to say the volume is length times width times height. But here, the base is a square, so the length and the width are both the same, and they are actually x minus 3 because they're supposed to be 3 meters less than the height, which I called it x. So I'm going to say let x equal to the height of the storage tank. Okay, in that case, the volume would be height times length, which is x minus 3 times the width, right? So the length and the width are both equal because we have a square for the base, and they're both equal to x minus 3, but the height is x. So that's the volume, but the volume is 20, we already know that. So I end up with x minus 3 all squared times x equals 20, and I came up with an equation just like that. Okay, but now the question is, okay, how am I going to solve this equation? So I'm going to try to simplify it a little bit. Okay, so I get x times x squared minus 6x plus 9 minus 20 equals 0. I expanded the binomial squared. Okay, and then I'm going to multiply x by this quadratic trinomial, x cubed minus 6x squared plus 9x minus 20 equals 0, and I ended up with a cubic equation. Now we understand why we spend all that time learning about factor theorem, about all those techniques of solving polynomial equations. Why did we practice that much? Because you see, end of the day, whenever you want to solve a real life application question, you end up with something like this, an equation like this. You need to solve it, and if you don't know how to solve it, then you will not be able to solve your problems in life. And that is the answer to why we all learn all the math that we have learned. So to solve this, I'm going to let this equal to f of x. And because the coefficient of x cubed is 1, we have to look at the divisors of 20, and they are plus minus 1 and 2, plus minus 4, plus minus 5, and plus minus 10, and of course plus minus 20. Okay, so 2, 4, 6, 8, 10, 12 candidates are there. So we have to find f at different values to see which one would be equal to 0, and then we can apply factor theorem. So let's try 2, f at 2. If you use the calculator, it's going to give you some number which is not equal to 0. So we see that this cubic polynomial is not divisible by x minus 2, or x minus 2 is not a factor of this cubic polynomial. We try negative 2, for example, and f at negative 2, when you do the math, again, you end up with something that is not equal to 0. We don't care what non-zero number that is. As long as it's not 0, then it's not useful for us. Then we try another number, f at 5. So 5 cubed minus 6 times 5 squared, 9 times 5 minus 20. Sure enough, if you use a calculator, you get the 0. answer. So what does that mean? It means that x minus 5 is a factor of f of x, or f of x is divisible, okay, divisible by x minus 5. So if it is divisible, what are we waiting for? We're going to quickly divide it, okay, and see what we get. Now, when you divide it by x minus 5, you have to use long division, but that's time consuming. So instead of doing it this way, we're going to use the shortcut method. Of course, you could continue use a long division method. Nothing is wrong with that, but it's just to save time, we can use this synthetic division method. And 5 is the root of the divisor. 1 times 5 is 5. Add them up. Times 5, negative 5. Add them up 4. 4 times 5 is 20. Add them up 0. And as we expected the remainder to be 0, actually it did become 0. So now we have the quotient x squared minus x plus 4. And this is the quotient. And these coefficients are coming from the last row of the synthetic division procedure. So now we can say that f of x is x minus 5 times this quotient. Okay, so we factored our cubic equation. That's all we did. Now the question is, can we further factor the other expression or not? Well, we want to set this equal to 0. See, it was 0, right? So either we're going to say x minus 5 is 0, or x squared minus x plus 4 equals 0. This was zero product property, if you recall. From here, x equals 5. And from there, if you calculate the discriminant, okay, unfortunately, that will be negative. Because b squared minus 4c is going to be 1 minus 16, actually, which is negative 15. So that quadratic equation has no real roots, okay? So no real solution, or no real roots, okay? So if that has no real roots, there is only one real root for this cubic equation, that is x equals 5, all right? So if x is 5, it means that the height must be 5 meters, and the width is 3 less than 5. So 5 minus 3 will be 2. So the width of the base is 2 meters. Therefore, the dimensions of the tank, okay, is going to be 2 meters by 2 meters, that's the base, by 5 meters, which is the height, okay? So that becomes the final answer to the question. They asked us to find the tank dimensions, and that's what we did. How did we do this? By using our knowledge of solving cubic equations, by our knowledge of factor theorem, our knowledge of solving equations, by our knowledge of knowing how to solve quadratic equations. All the math you have learned in the past, you use it to solve real-life word problems or applications. There's many problems like this that I highly recommend that you study those, review those. There are solved examples in the textbook, or there are homework exercises that you may try. And then by practicing and practicing, you will become better and better as the time passes by. So good luck and thank you.